Alright, took too long to get started, but let's go. Doing 3 sessions today, and then maybe more once I'm watching dogs. Okay, let's go. What are we doing? More passing by address? Oh yeah, we did that last night a little. Where's the water? Nice. In this I wasn't fully understanding the point of. The point here is that we can either pass a location to something valid or not. Like sometimes we want to call this function with no arguments, no address of anything, and sometimes we want to call it with them. I don't know when I would want to do that right now. I'm trying to think. Like it seems like you'd only do that for hard-coded stuff, and I wouldn't want to do like that. Do something like that. I mean, like maybe there's a function that displays a like an outline, like a, let's see. Maybe you're like some sort of predator type character, like the one with the dreadlocks and the fucking eyes that can see infrared. And normally your vision is standard visual spectrum, and you're good. So when we call the function, we manually call, let's say it's part of like a cut scene or something. Oh, I guess that's what you could do, huh? You could say that there's like a there's a like a lock on target thing function that we call, and then it is a helper function that calls one of two functions. Either a function that doesn't do shit and just says, hey, there's no target, so you still see visual regular, or so we're calling a function with no, we're calling this other function I'll say in a second with no arguments, excuse me, and then just outputting, excuse me, goddamn fruit, I guess, excuse me, and then printing no target found or something, or we're calling it with an argument, and the argument is the actual target. Is that something I would want to do? I mean, I guess I could call the function. It just seems like this is a manual thing. This isn't something I would actually have in a game. It seems like something for a cutscene. Like when this cutscene happens, and there's code that's executing different things that are going on, and it calls this function with no object as an argument, no address as an argument, no pointer, and then the function receiving the call, or the function getting called, same thing I guess, the function getting called has a default pointer parameter of null pointer. So by default, it doesn't put a UI up and do this visual stuff. Or at another specific time, timed in the game and called at a specific point, is a call to it with a pointer that overrides the default argument of null pointer, initializing that pointer parameter. Fuck, I have like dry skin in the middle of my hand or something. Trying to see when I want to use this. Let me just make an example and then see if something comes to mind. No, I don't think we need this yet. No. Let's do. Oh yeah, because this is. We could do this either way, just via overloading. So for optional arguments, I'm just trying to rehash the last little bit of what I was doing yesterday because I was tired enough to where I wasn't getting the full meaning out of it. Usually I get a good feeling for when I understand something enough to probably use it and find use cases for it. I'm not there for this yet. It's like Subnautica. I've scanned two out of the 4 pieces for the blueprint, but it's not there yet. I need 4 in order to be able to use the thing. Oh, okay. So if we didn't want to do overloads for some reason, and we wanted to use pointers. Alright, whatever. Let's just say void update void like void print thing, and then it's just I fucking insert selected. Where is insert? There we go. Oh, fuck me. Or what is it? There we go. Okay. And then we'll just do sure again, int pointer, or we'll do a const int pointer. Does it matter? Yeah, it's fine. Thing, sure. And then yeah, we actually do need IOStream. If thing isn't null, then and let's do cool. Oh, well, I guess we could say this. Yeah, same issues. I made the same mistake as last night. Whoops. Let's handle the null case first. What? Oh yeah, it's gonna say like, oh wait, hold on. Oh yeah, and am I retarded? If thing, then it returns. Oh, I didn't have the fucking colon. Still? Okay, it's fine. It's like, bro, what are you having issues about? Wait, why wasn't it caring about... Oh, okay, there it was. The IntelliSense didn't update at the same time, I guess. It didn't, it was missing... It wasn't giving me that error. It wasn't updating to say, hey, it's not... Null isn't the issue anymore, it's just the fucking semicolon. Yeah, because the whole point of here is, if the pointer is null pointer, if null pointer, then fucking say we don't have anything to print, and boom. Otherwise, print the thing. That way, we can have an x is 5, and then we can just do print thing, and pass it the address of x. Or we can do print thing with nothing. Like that. So we can say, hey, there's 5, or there's nothing. When would I want to do this? So I could just pass a reference to something to print the expensive thing, depending on what the thing is. If it's, or yeah, I could do it like if it's a standard string. So if it's a fundamental value or fundamental data type, we could do pass by value. If it's an expensive one, we could do pass by reference. And then I could just do nothing if it's an empty argument and we don't want anything to happen. So I'm gonna say, hey, I can, if we don't have anything to print, I'll call this. If I do have something to print, I call this. But I'd rather just call one thing and then it determines if there is something to print. But maybe, like, why would I want to call this with no arguments? Why wouldn't I just call it here with one feel like I would call it with an argument. Why would I call it without an argument? I would just check to see if the thing is valid or not. Why would I be calling why, a function where I pass something by reference? Why would I call it? Well, let's see. I'm thinking about like blacksmithing in a game where I open up the UI and when I have features so that when I click something, it sets a pointer to point to that thing, so that's the selected thing. And while the pointer is a valid thing and it's visual, then it highlights it. So that's how I could have highlighting. It's like I click an item and it's highlighted, I click another one and it's highlighted, and it unhighlights the other one. Excuse me. And I could have a thing where it saves the reference of the last highlighted thing, and every time we click, it updates the last one, and it checks, hey, if the newly highlighted thing is different than the last highlighted one, then unhighlight the last highlighted one, because both references would be stored there. And maybe that needs to be a static variable in that case. Maybe, I don't know. Yeah, right now I'm not finding a use case for this. It's fine. I've had other things like this before. Yeah, like I'm aware of what's happening here. Yes. We have print ID number, and we're using the default argument for this pointer to be null. And in this case, it's saying your ID number is not known. In this case, we'd rather just handle not ID, and then otherwise print the ID number, but it's fine. Just so we get the fuck out as soon as we know that this isn't valid. So we're not trying to validate and then doing other stuff, and then finally, oh, it's not valid. We knew it wasn't valid. Just go there. And then we can actually get an ID and then print that too. But I don't know why I would ever call this. Yeah, like why would I call this before there's an ID? I mean, maybe for a game you spawn in like some spaceship and you need an ID card for something, and there's a helper function, like I was saying earlier, a helper function for use ID, or like, yeah, fuck it, use ID. And we call it. I feel like I would rather just have a namespace, or I guess if we say it's in main, I'd rather just create the variable from the rip. Let's say for some reason we can't create the variable from the rip. We have to create it later. And so we make it so that when we call print ID, I feel like I have to have two separate functions then almost. Like, if we're calling without an ID, like I could have a helper function. Do I even need that? Like if the character presses C to use your, like E is normally the interact button, but C is better because it's closer. You can just close your finger near there instead of having to extend it and reach out. So you press C to interact. You don't have an ID. Like I'm gravitating towards just having ID exist from the get-go, but I set it to be an invalid ID or it's missing or whatever, and I could have different things for each one. And we call print ID and we pass it user ID. And if user ID isn't the expected value or the value that we need to open that door, then it does some other shit. But we're only ever calling it, and we're only ever calling it with a reference to our current ID. Or would just pass by value because this is a fucking fundamental value, so it'd be a waste to do it otherwise. Or, sure. Or, sorry, this is pass by address. I mean, so either way, whatever. We're doing pass by address. I'd rather just copy the value or pass and look here, and if the value isn't what we want, as long as it's valid, then don't do anything. Instead of having something separate to call this. Like I almost need a different function that determines when we call this way versus this way. Because these aren't just things that happen one time. These are things that happen every time the player presses his E key. Or every time he opens up or tries to open a door that requires an ID card. So, you try and open the door, it should just be calling the same function instead of... I mean, it's calling the same function, but it should be passing the same shit every time. Because otherwise, I need some sort of condition during the call. Are we calling with no arguments, or are we calling it with an argument? I almost have to hard code it this way. I mean, maybe I had certain times and delays. Like, I could see this working in like an Arduino context, like embedded C++ or something, where let's say a cutscene is playing, and in the beginning, we call something with nothing to turn off the lights. But then 30 seconds later, I know that this code is going to execute, so there's like a 30-second delay here for this line. And then we manually call it again, and we pass in the LED effects. So at first, we turn the LED effects off, we make sure that they're off, and then it's like just calling the same thing with a different argument. In this case, it's default. So it's like calling this with activate LED off, activate LED on, something like that. So we do one, and then we do another after a while. But this isn't something that we would just have going all the time. I have to hard code this. This is stuff that I want to happen on a loop or not with unpredictable user input. Yeah, I don't really like that much. I'll be right back. A fucking pimple on my lip that's pissing me off, dude. Alright, we're good. I always touch my freaking chin whenever I'm learning and programming and shit. I guess on the computer. And then it just feels unnatural. Okay. Bro, what the fuck is happening here? Oh. Forgot I was checking some stuff out with my PC's, my mouse's cord, so I pulled my PC out further so I could get behind it and put the cord in another USB port, but I didn't push the PC back because I'm fucking stupid. Alright. Yeah, we could just do the exact same shit with overloading. Excuse me. Excuse me. Oh my god, dude. Fruit or something. I've never burped like this. Bro. So I could do that. Okay, no ID. ID is 5. Or we could do... Or we could say... Sure. We don't want to do anything unless the ID is valid. And then in this case, we're passing an address of... Cool. Same shit. Hey, we're calling it with nothing. Cool. Hey, we're calling it with a pointer to something. Okay, cool. Or we could do a reference to ID, and then we just pass it ID again, and then we don't need to dereference anything. Please, just go. Boom. Same shit. Okay, cool. Now also works with R value arguments. Oh yeah. Well, and if we wanted it to work with R values, instead, I mean, it's a fundamental value here, so sure, we would just do same shit. Yeah, this is passing by value, but if I wanted to do like an R value and keep it in memory, would I even want to? We could just do a constant reference to 5 and then do that, and then oops, this needs to be a reference, and in this case we're just passing by value. Oh shit, hold on. Oh, now we're copying value from a reference to an so there's a temporary that exists. We have a reference to it that's not an object, but it refers to it, and I'm copying the value from the object. Or I can just actually pass the... I think the thing itself. Hold on. What are you fucking complaining about? Oh, this needs to be a constant reference because it's an R value. Boom. So you can do it a bunch of different ways to solve the same thing. Still wouldn't want to do it, but it's fine. Yeah, and with references, we don't have to worry about fucking null dereferencing. Yeah, we don't have to check conditions or anything. Yeah, so in that case, there wouldn't be a point of doing this, because this has to be valid. Changing what a pointer parameter points to. Yeah, the address is copied. Yeah, yeah. Yep. Oh wait, I think I already did this. Oh, we're talking about, wait, isn't this? Yeah, exactly. Oops, I forgot. Pass by address. Wait, what? Hello? Oh, this guy. Okay, yeah. Yeah, we already did this. So we said, hey, if we want to change what an actual point... Oh, up here it was saying, hey, we had another pointer that's initialized with the return value of this guy. So if we change this guy, it's not actually changing our pointer. But we can pass the pointer by reference, a reference to an int pointer. Cool. And we can change it. Yep, sure. Because we can go in there and change the reference to the pointer, which actually updates the pointer, and boom. So we go from having x, reference to x, it's valid, but then, or it's non-null, but then we nullify the pointer, and then it actually does do null. Yep, cool. Reference to a pointer. Yep, makes sense. Fuck it, I don't care. Fairly uncommon. Okay. A pointer to a reference or a reference to a pointer? Hello? Reference to pointer? Pointer to a reference? Why would I want that? Oh, I guess you can, huh? Oh. Oh, gotcha. Is that true, however... Is that always true? an integer a const int reference and a pointer to it. Okay. We just say if thing is null, do nothing, otherwise dereference it. Cool. What are you fucking complaining about? At all? Really? Pointer to reference is not allowed. What about, didn't they say though that a reference could become an object if it's storing a temporary variable, but maybe not? Or if it's keeping a temporary alive? Maybe not though. Dang. Okay, noted. Noted. Can't do it. No references to or no pointers to references. Okay. Why? Alright, good. Finally, I've been waiting for this. Defining a pointer to void as 0, maybe? I figured the syntax for that would just be defining a pointer to void space 0. Not the parentheses stuff, but I guess not. Yep. Oh, gotcha, because the point is if we're passing 0 instead of passing null pointer, or passing null, which is just 0, maybe, then maybe we have an overload that has, okay, I'm gonna guess that we're going to see something like this. Sure. And at first we have an int value, and sure, we'll just say okay. Okay, and that's for integers. And then we also have do thing with value, and it's an int pointer. All right, we'll just say it's a const int pointer value. If value isn't valid, we don't do shit. Otherwise, we output that is value at address. Excuse me. Holy cow, dude, the burping is insane. Is dereference value. Cool. What are you complaining about? Can I do this? Fuck, same thing. I guess it would ignore white space, so I should have anticipated that it would do that. I mean, I guess this is the same in this case, because we don't want to do anything if it's not valid, so I'll just say, okay, as long as it's not null pointer, we're cool. Okay, and then we'll just say, all right, we call do thing with value and we pass it 0. Okay. We think, oh, 0 is the null pointer value or something, but nope. Ooh, let's try see what happens here. Uh-oh. Oh, ambiguous, yeah. And then, null pointer. Oh, it's actually, okay, in this case, it is not ambiguous because it's probably choosing integer value. And we can see what it's doing. Oh, yeah, it's prioritizing int for both. So it's going to say integer value. Oh, true. And then null pointer. Or we could just say if not. What the fuck are you doing? Okay. So we want it to pass null pointer. Well, if we have an overload, it's going to choose the integer overload over here, over this, because 0 is prioritized as an integer. Same with null as 0. Unless used in a pointer context. So if I removed this, it still works and it's treated as null pointer. But in terms of the hierarchy, I think it's probably because it's a direct match with integer versus being converted to a null pointer. I think that might be how that's being interpreted here. So yeah. I think that's probably it. Yeah. Yeah, and then here we go exactly in this case, and he's gonna pass it a valid pointer. Sure, that's cool. We pass it 0. Uh-oh. We call null. Uh-oh. We pass no pointer. Oh, good. Probably because GCC and Clang don't automatically maybe because on those, well, is it because Visual Studio is able to discern whether 0 is an integer or a pointer first? If on GCC and Clang 0 and null need to be converted, or hold on, null is the one. So if null is defined as 0, if it sees 0 and 0 is always a pointer in a pointer context, but 0 is also an integer for an integer context, maybe. I think it just depends on the compiler and how much conversion is happening, how it's interpreting null. Because Visual Studio doesn't give a fuck. It says always integer. Alright, let's see. Visual Studio does the int. Alright. Yeah, so we can overload. Yes, we get problems here. Well, null is already included in IOStream. Cool. So we have an overload that, well, whatever. I'll look at main first. We have an integer. We have a pointer to an integer, modifiable, with the address of an integer, x. Cool. And then we are printing that valid pointer. And then we're printing 0. And then we're printing null, which could be a pointer, or it could be 0. Or it could maybe be both. And then we're printing null pointer. The point is, at least in C++, null pointer is explicitly a pointer. 0 is explicitly 0, unless we're in... I guess it's not explicitly, but no pointer is always a pointer. A pointer is always a pointer. 0 is an integer unless a pointer is the only... Unless integer is not an option and pointer is. And then same for null. So it could call it could call the pointer one, which it does if we don't have an int version. It could call the regular int one. It does because 0 is more closely matches an integer than a pointer. It seems like there's some sort of conversion there. Or be ambiguous in a context where it matches both off the rip, or it seems like ambiguous by definition is when there's a conversion, so it doesn't automatically match pointer and it doesn't automatically match 0. So it's being converted. Maybe null is not just defined. And well, actually, no, it's the compiler. So we're still talking C++ here. We're just talking about how it's compiled, how it's interpreted, how it's converted into machine code. Okay. Yeah. Non-null, 0, 0, and null. Yeah, it probably isn't. Yep, exactly. Visual Studio makes sense. Yeah, it prefers that, which can be unexpected when we wanted it to be calling the pointer one. Yep. When null is defined as value 0, yep, it also calls it. Oh, but if it was another definition, oh, so maybe it depends on the compiler, like the different in the case where it's defined, so different things define it in different ways, maybe. Hmm. Yeah, because maybe in some other context we define null as a pointer to null pointer. Standard null pointer t? Why would I want that? Since null pointer. Oh, what type is it? Okay. So how is it differentiated from integer overloads? Yeah, I guess it's not. Well, it has to be a type of pointer, right? Hold on. Well, the point is a pointer is of type something. Well, if it's differentiable from an integer overload, hold on, let me reread this. It's a type null pointer t. Can only hold one value null pointer. If we want to write a function that only accepts a null pointer, then we could have a null pointer t accepting function. Why we would want to do that? I don't know, maybe we want to... That doesn't seem like we would want to, but... Oh, well the point is that if we want to make sure that there's no target, we can only complete the quest after the target's dead, and the target only... Okay, so we could have like... I'm thinking like something like Fallout. Void complete quest, and it takes... Sure. A standard null pointer t target if not target. Well, hold on. Does that mean... I mean, that should be correct. Well, it seems like the call wouldn't work if we didn't, so we could just say Okay. And we could say alright, we have a standard string. Excuse me, and I mean, in this case we want a pointer, so I mean we could do this two different ways. We could just pass a still. We could just have a standard string that's a target. We eventually update it to be blank and just pass a string view here. And it just checks, hey, is the string blank? If so, good to go. Or, and that's probably the best way. Or we could have a standard string. Let's make it a const standard string. Oh, and let's say const standard string bounty target, and his name is Z. Okay, and then we have a pointer to a well, hold on. Well, yeah, that's fine. I think I can have, no matter what type a pointer points to, it can still point to null pointer, I think. So we can have a const standard string pointer and call it target, and it gets the address of bounty target. And then we try and call complete quest target. And in this case, it would copy the value and check to make sure you're pointing there. But no, because it's incompatible. If this was, but if we instead, you can't complete the quest. But if we say now target is null pointer, so the pointer still can't be set to that, huh? I guess the whole point is you would just have to call it differently. We'd have to say, we'd have to track it somehow. So we'd have to actually maybe have another fucking standard string. We just have to call two different things. But then I need a condition. If the target is dead, let's say bool is target dead, and now we make it false. Then we call complete quest with, oh, true. Well, I guess we can't have a one pointer and then do it. We just call it in one case. If I tried to call it with bounty target, no bueno. But then if we said bool, or hold on, if we said if is target dead, so if the target is dead, then we call complete quest with null pointer. Or, oh, I guess I could just do an if else. Hello? Call complete quest null pointer. Else call complete quest with bounty target. The problem here is, nope, 17 is an issue, and the issue is here. So its target is not dead, nothing happens. Target is dead, dead. Okay. If we want one that takes one type of pointer versus another, I can call one that only takes, so that's the thing. Null pointer See, the thing is, this is okay. But if this was... This is not okay. Oh, well, this needs to be... Oh, wait. I thought for some reason there I couldn't initialize the target to then be null pointer. Wait, what? That was the whole point of this. There was no issue there. Hello? And right now, it's not... Can I just do maybe unused? Oh, the point here is the call. Wait, hold on. So the point is, this is fine. But I can't pass this type of pointer here. This isn't a null pointer type pointer. I could do a const standard string pointer and then say if not target, do this, and then call complete quest with target. So I can give it null pointer. I just have to give it null pointer through a standard string pointer, not a standard null pointer t. So the point is, it only accepts literally null pointer t. Like that. Why I would want to do that, I'm not really sure yet. I would rather just set a pointer, well, I don't know. Not really sure right now. Oh, accepts only a null pointer literal argument. Alright, well, that's one of the costs I get for trying to go ahead and figure stuff out in advance. But it's fine. Oh, and I guess the page is fixed now? I can click around? So you can print null pointer. We can make an integer 5 pointer, print pointer, calls the other one, and then I could have pointer is null pointer, and it still calls it because the type, yeah, even though pointer is null pointer, it's still going to call the int one, not the null pointer one. Resolves to the function. Resolves to the function. Yeah, it's calling the function, the overload print standard null pointer over the other, because there's no conversion required. We don't have to convert from null pointer. Well, null pointer is an exact match compared to null pointer being converted to an int pointer. Yeah, on types, not values, therefore, okay, yeah, makes sense. And the point is that there's no way to convert from one type of pointer to a null pointer type. It's a pointer to this versus a pointer to that. Is there a static cast option? Nope. Cannot convert it. Dang. Pointer types will not implicitly. Well, apparently not explicitly either, buddy. There is only pass by value. Okay. Compiler can optimize references away entirely, so that it's just referring to the literal object, or well, not the literal, but to the object, the referent. Cases where it's not possible and a reference is needed. Pointers. Behind the scenes, pass by reference is pass by address, but it seems like it's made cool in a way so we don't have to dereference it, and it's and it must be initialized with a valid reference. Can't be undefined, or it can't be uninitialized. It's like a safer way of using pointers, maybe. Yeah. Yeah, because we have two separate things. We have this temporary R value address of something, and then we have a parameter, an L value, that holds an address, and we're copying it by value. Yep. C++ really passes everything by value. Meaning that even if the point is that if references are pointers and copying by value is taking an object or taking a temporary object even and copying its value into a separate other object, passing by address is taking the address of an object and copying it to another separate object. It's not two objects, it's not operating on the same reference. It's operating on a pointer to a place in memory, so it's really just different places of memory looking at the same place to operate on it. So even when we're passing by address, sure, we're actually passing by value, but we're passing the address by value and then operating on that place in memory. And the proof is that references are pointers, and pointers pass addresses by value. It's just that it ends up actually changing the thing at the address that's passed by value. Properties of pass by address and reference come from the fact that we can dereference in the past addresses to change the argument. Yep. Which we can't for a normal value parameter. Yeah. Okay. Yeah, it just happens to be that we're operating using the copied value that doesn't get tied to any particular piece of memory. It's just a value versus a value that if we dereference it actually brings us all the way down to wherever the object is in memory that we can then operate on. Okay. Yep. on. We avoid making an expensive copy by utilizing passed by const reference. If we don't want to change the thing, sure. If we just want to get the value somewhere. Or passed by reference. And it could be, or sorry, an address. But it could be passing a pointer to a const. A pointer to const standard string, for example. So when we return by value, what would be the point? If we return by value somewhere else, we have a temporary. The problem is that when we call, we have a non-temporary place in memory with this value. So we can look in the function, we can look at it because it still exists. When we are returning, that value we're returning is an R value. It's temporary. So if we passed an address, I mean, I guess we could pass a const. How would that work? Would we treat it like that? Where whatever value we're going to return, if we need to return it as cheaply as possible, and we want to use it directly and not copy it into anything, so there's no copying of standard strings or classes, then we could make a const reference to a standard string, which lets us return that guy. We return that. So we return a const reference to standard string. So in this case, we're returning an L value reference to const, but it's really to an R value. But that R value's temporary object, that R value, which is a temporary object, is its lifetime is prolonged by the reference. Turn that. But is the reference destroyed then? That's the problem. If we have a function and I'm returning that, but then I think I'm destroying it, so then the reference, but maybe I already have the value at that point? I'm not sure. I mean, here's some stuff returned by reference. I'm not super sure. Yep, also expensive. So sure, we've negated half the cost by removing, I guess negated half the administrative cost, which is the cost of copying a standard string to the parameter. But what about the cost of copying that value back? There's a reference that is bound to the object being returned, which avoids making a copy of the return value. Now we return a const reference to it, okay? Okay. This program is named. Get program name. And the point is, there's one place of memory with the value, and we want to use that value, and that's it. If we are going to copy the value to initialize something, I think that copy has to be done. It has to be copied. But if we want to just use it, and that's it, then we just return const reference to the thing, which is exactly what I was saying earlier. Oh yeah, we could actually do this to be kind of cool. Can't make it const because it has to change. Standard character input. White space. The fuck? 1 of 4? What does that even mean? Oh, different ways of doing this. So getLine returns a stream, or like a piece of a stream. Oh, and it returns a reference to it. So it's returning by reference, it looks like, but not const. And there are different things it could have. I don't know what this stuff is. And they're different. I'm not sure how this stuff is happening. A reference to a string, a reference to a different, to a stream and a string. I'm not sure. Okay. Oh, so it needs a stream and it needs a string. And this is the string. So this is a stream. Username. Return. Username. Bro, are you tripping? Yes, that's what I was thinking. Man. Yeah, and the point is that this would be prolonging its lifetime. To at least have this look at it. But then isn't the reference destroyed here? And then this call is activated? Or evaluated? Oh, it does have to be static then, huh? So that it's not destroyed, is that the whole point? Because I was saying earlier the downside of this would be that we have to make the shit that we want to return static. Which means that it's not destroyed till fucking way later. So sure, our calls are cheaper. So I guess it's saying that, hey, like your operational costs are cheaper, but your initial startup is more expensive. So like, you have this much energy you can use, and we have to reduce it. Oh, you only have this much you can use, because this guy exists in memory the whole time. We only have this much memory, not this much, this much. But instead of using so much at a time for these copies, we're only using little tiny bits to access the memory. Excuse me. The problem though is now this guy is static. And now whenever I call this again, sure, whatever, we'll just print it multiple times. Each time we're updating it. So I guess it's okay. Yeah, that's the point. It's my critique or my potential concern. Yeah, exactly. It must exist after the function returns because we return, but then the function's dead. And then we're using that reference to get a value that now isn't referable. Oh boy. And really the reference doesn't exist anymore. Well, yeah, then the object doesn't exist anymore because if we are returning a reference to this guy, and then here, everything in here is destroyed. Or I guess the point is we're returning this here, and then this is destroyed, specifically this guy and the temporary. Or the local that doesn't exist anymore. We need a way to refer back to it, because otherwise I guess we're doing technically a one-time dangling reference. Mm-hmm. Yep. Using return has one major caveat. The programmer must make sure that the object outlives the function, which means it's got to be static, as far as I can tell. We could do the same thing via address too, huh? So we could say this static standard string. Oh, not static. No bueno, you're just gonna get a warning. And then you're gonna get a dangling reference, bucko. But we could return a pointer to it, but then we're returning a pointer to a piece of memory where an object used to exist. Same thing. Curious what the error looks like for that. So if we make this guy no longer static, returning address. Yeah, it seems like, I mean, because we know that this is still the same as passed by address, really. But now we're returning a pointer to this guy. So we are returning the address of username. Same error, I think, maybe. But here and here, oops, here, we need to dereference this guy. Same thing. Cool. Makes sense. Just that reference is a cleaner way of doing it. Yep. Because it still exists. Yep. We return a dangling reference. Why is it dangling? This guy exists. We return a reference to him. Oh! Returned. Destroyed. Reference to what? This program is named. Get program name. Returning a const reference to a standard, or a reference to a const standard, or a const reference to a standard string. Const standard string calculator. Return reference to the value calculator. reference to this object, this place of memory, this address with the value calculator. But then we've returned, but before we actually evaluate it, standard string program name is destroyed. It's no more. Now we have that reference, that address. We go and look there. Ah, fuck. It's not what we expected.
It's undefined.
All right. Yep. Turn it and then it's destroyed. Now it's dangling. Yes, sir. And I guess if we're saying a reference that's bound to something, we're really saying... I'm not actually sure how that works at a deeper level. Does this turn on and off the mic? No, it doesn't because there's no mic attached to this thing. Okay. Because if a reference is not an object, but it still looks at the address of a thing, I'm not sure how that works exactly. Yep. The objects returned by reference must outlive the lifetime, or well, the program, or the function, sorry. Never return non-static boys by reference. Unless we're talking about like a global const expression guy, but it's or a local const standard string and it's the name of the enemy and it's expensive as shit, or it's like a property or something of a class and it's the name and it's a standard string and I need to call it out. I need to print the current target, not copy the value anywhere because otherwise I still have to copy the value. But if I'm just trying to use it and look at it and read it without copying it, then, because that's the problem, if I call a function, there's this copy cost. I just want the function to look at the value. I don't need to copy it in there. But if I also only want a function to give me a value that I'm not copying, I don't want that cost either. I might not be able to get around it because I need to actually copy it. I need to actually store that name in memory. But if I don't want to do that, well, return by const reference. So I could return in a function just a const reference to an existing global variable. And that's totally fine because it outlives the program because it is global, therefore it automatically has static duration. Lifetime extension doesn't work. Yep, that's what I found out. I tried. I made an L value to const reference. I gave it an R value, and nope, it did not extend it because after we return, the reference doesn't even exist anymore. So, nope. We just have the value of the address. Yep, so we have 5. You'd think, oh, hey, it's a const reference. L value reference to const, but it's given an R value. Okay. You think, oh, it's going to prolong the value of 5 until it dies. The second we return it, it dies, so it's gone. Constant reference. Oh, yeah, to see if we can store it. No, sir. because we're returning a reference to this guy. It's returning an integer literal. The return type is a constant reference. Creation of return or a temporary reference bound to a temporary object. The returned reference is copied into a temporary reference. The object is gone. Seems like it's the same shit. So the object must persist past the lifetime of the program. And if you can't make a static literal, well, no sir, can't do it. By the time the temporary reference is bound to const variable, oh yeah, because we've returned, or hold on. Oh. Oh, in the scope of the caller. The point is, by the time the temporary reference has been returned to the caller, the function is completed and it's gone. Okay, we have constant reference 5, and we're extending 5 because why? Because we're specifically in the same scope versus just trying to make sure I understand why it's dangling. Return by const reference 5. So say, hey, here's 5. You now have. So it should be returning the same shit. We pass it 5 and it returns 5. But it's the value of 5. And the address of wherever it is, but it's dereferenced. Say pass 5 and it's a reference to an L value reference to const, but it's initialized with an R value. Okay. But then when we return it, we are returning a const reference to it. But because it's in a function, it gets destroyed and we can't do that. Case 2, a temporary object is created to hold 5. Okay. So 5 is a temporary R value. Ref in the function binds to it. The function returns that reference back, which uses the reference. Hold on. Returns it back to the caller to initialize ref2. Because it isn't a direct binding to the temporary object, the function, it's like the function is like a moon that obscures the message when we're sending a message. People are living on Mars, and an easier way to send a message to them is to send it through the moon, but the moon obscures it and it doesn't actually get there. So it doesn't work. We have to do it direct. It has to be a direct reference to it. Okay. So warning. Reference lifetime extension doesn't work across function boundaries. Okay. Don't return non-const static local variables by reference. So if it's a static local variable that exists over time and it's non-const. Oh, because what if I change it in another function and then I call that function again? And that function is expecting the value to be whatever happened last? But now we don't know what happened to it because now we're looking at it. Yeah, it's like, it seems like this is the same as using a non-const global variable, really. It's just that now we can actually access that. Like before we thought, oh hey, static local variable, woohoo! It's got internal linkage, can't do anything about it. And actually, sorry, no linkage because It's a static local variable. The lifetime is longer, sure. Program start to program end, initialized once during its first during the first call to the function, or at least the first initialization, and the value persists after. But if I get a reference to where that guy is, it's just like getting a reference to a global variable that exists that's not constant, and I'm changing it everywhere. So it makes sense we would want to return a const reference, not a or I guess the point is, it would need to be a const static, or can I just return the reference and then not allow the changing of it? Oh, I guess the point is if it's not non-const. Well, so the const doesn't the reference. Hold on. In the example, hold on. We return a const static local variable. Just again. But if we return a non-const static local variable, we get some issues. So, excuse me. We have a reference. So we're not using it once, we're actually storing it. We have a reference to a static local variable. And again. So we're calling get next ID. Next ID is static. Hold on. So it's 0 at first, and we increment it to get 1 for the first. We return a reference to it, and it's 1. So the first one gets 1. But then, if I call it again, it's not going to be a new unique copy, 1, 2. We're getting a reference to it. Seems like we would want the value of it, not the reference to it, because now it was 1, now it's 2. And then we return a reference to it. Well, those references are looking at the same place in memory. Wouldn't this be the case even if it was const? Oh, well, the point is, if it was const, then it wouldn't be changeable. So we don't want to look at changeable ones. We want to look at things that aren't changeable. Okay. Yeah, it's the same object. So when anything modifies the value, every reference is looking at the same spot and they see it. It can be fixed by making them normal variables instead of references so they get the value of it. The value of it, right? So we're not looking at the place. We're taking it. We have the reference. And the type here determines how it's received. The type here determines how it's received. So the type here says, hey, we're returning a reference to this guy, not a value to this guy. And if we were returning a value to this guy, then we're getting a reference to the temporary? If that even works? Hold on. What happens if I do that? I think I'm going stupid mode right now. Yep. Yeah, it's because it's a temporary, and the temporary can't be converted to an int reference. It can be converted to a constant reference though. Initial value of reference to non-const must be nil value. In this case, we're using a temporary value. So it's just the syntax of how the reference works, I think. Okay. And so if we want to just I could look at this value in memory, but anytime it changes, if I had multiple variables for it looking at the same place, they get fucked up. So instead what we want to do is, sure, instead of copying this to a temporary and copying it to our local variable, or yeah, instead of copying and copying, we just copy it once. So we get an int reference. We return the reference to this guy, and this is just int x. Hold on. We're returning a const int reference. And it needs to be, oh wait, we can't do that because this is a literal, so it needs to be static. Static ID is 5. Increment ID, return ID. What is happening here? Static int, whoops. And y, get value. So instead of saying, hey, oh, this is just an int, we could do the same thing. This value so we have a variable here in the function, and then we have a variable in another function. Oh my. And I think the point is that we're returning an R value, a temporary, which is this guy. So it's not this guy, which is a static local variable, an L value. It's not this guy, that's an L value. It's this guy, this little R value return boy. So instead of doing a copy of this parameter or this local variable, or it could be a parameter with the default value, to the temporary, we instead just return a const reference to it. So now it's just looking at that place in memory and copying its value here. So we get one copy. It's the cheapest way. So, cool. Don't return non-const. Okie dokie. That's round 1 of studying Dunzo.